Hello, welcome to Wednesday's edition of Cracking the Cryptic, where today we're going to take a look at a very interesting puzzle that's popped up on Facebook, and also Sed sent it to us from Sed Holaysan in the Philippines. Now Sed's featured on the channel before. His puzzles have always been popular, so I'm looking forward to trying this and looking at the Facebook group who some of the people who've liked the puzzle. They are people I really respect, so I suspect this should be a very, very good puzzle. And I'm taking a bit of a flyer on it because none of our testers have solved it, and Mark hasn't either. So I'm relying on Facebook, which I don't normally do, but we shall see how it goes. Now Sed's got a book out as well. I wanted to mention this. He flagged this to me a few weeks ago. It's called Philippine Sudoku, and look at that, 100% handcrafted puzzles, 31 Sudokus, and it's pay what you want. So you pay what you think Sed should get. Now I hope that you guys think he should get something. I definitely do. So yeah, take a look at that. I think it would be very worthwhile. I'll put a link under the video. A couple of other things to mention. Patreon. Mark is going to be putting up a solve of his double, well not his, but his solve of the double Choco puzzle that featured in Alex Bellos's recent article that came from the UK Puzzle Championship recently. That's a puzzle by Robert Volmert, so one of the best constructors of puzzles in the world. Definitely worth checking out. Also on Patreon, you'll know that we have our puzzle hunts at the moment. Now the adult puzzle hunt is proving very difficult. We've still only had 3 correct solutions, so I'm going to put some hints up. So look out for that. They won't be behind the paywall. So anyone who's still struggling with the adult puzzle hunt, pay a visit to Patreon, and you should find some assistance there. And also, just a teaser for you, we're going to be putting up another puzzle hunt very soon. This one is being created by a young viewer. Nicholas has come up with a lovely puzzle. It really is beautiful. So we're going to share that with you in the next couple of days. So do look out for that. I'll flag it in a video nearer the time. Now, how does this puzzle work? Well, let me read you the rules so that there is no ambiguity. Classic Sudoku rules apply. If 2 adjacent numbers, which may be 1-digit or 2-digit numbers, read from left to right or from top to bottom, have a sum of 50, then L must be placed between those numbers. If they have a sum of 100, C is placed between them. That's obviously from the Roman numerals. If there is no L or C, then 2 numbers cannot have a sum of 50 or 100. So let's think about some examples of what this means. So let's use this L as an example down here. That means we need to consider, we're reading, because this is an across clue, this L is dividing sort of between column 6 and column 7 here. We are either taking this 2-digit number and adding it to a 2-digit number on this side, and we're seeing whether that equals 50, or we're saying it's a 2-digit number plus a 1-digit number the other side, or it's a 1-digit number this side plus a 2-digit number that side. So if any of those sum to 50, you have to put an L between them. If they sum to 100, you have to put a C between them. And the only other clue I noticed as I was typing this into our software that it might cause concern is this C here, which is not dividing, it's not on a sort of column division, it's on a row division. Now this means this is a vertical clue. So what we have to compare here is whether this 2-digit number plus this 2-digit number, they could equal 100, and that would require a C in this position, or it could be just this single-digit number plus a 2-digit number below it, that could equal 100, or it could be a 2-digit number plus a 1-digit number. So one of those things must be true for there to be a C in the grid. Now that's all we know. If you want to have a go, I definitely recommend it. Click on the link under the video, and that will take you to this web page where you can play along. And with that, let's get cracking. Let's see how we do this. Oh, just a quick thing that I also noticed as I was typing this in. Look at this beautiful construction. 1, 2, 3, 4, 5, 6. I mean, there's only 9 given digits in this crossword. Whoa, I'm going crazy. In this Sudoku, and a few L's and C's dotted around, but that's it. Not a lot of givens. We can do something with this L clue though, can't we, straight away, because if this was a 2-digit number plus a 2-digit number, either there would have to be a digit that had sort of a number from 10 to 19 in it, or there would have to be a number from 20 to 29 in it. It's not possible to make two 2-digit numbers add up to 50 any other way. So this 1 and 2 are sort of quite powerful. They mean that one side of this L clue must be a 40 number. So there must be a 4 either in this square or this square. That must be true. Yes, okay, and that means, I think, that this square... Oh no, I was about to say in this square, but that's not true. It could be those two squares have to add up to 10. It could be, if this is a 4, it would be those two digits. If this is a 4, it would be these two digits. No, so we don't know. We do know, though, that I suppose 4, 6, 1, 9 and 2, 8 are ruled out. So this square has to be a 3 or a 7. And one of these two squares has to be a 3 or a 7, but we don't know which. But the C clue is interesting now, because there's a 4 up here. So that means, if we think about the options for this C clue, if it's a 2-digit number plus a 2-digit number, this would have to be a 4, because this would have to be something like, I don't know, 43 plus 57 or something like that. That means this would have to be a 4, and it can't be a 4. So this is not a 2-digit number plus a 2-digit number, so it must be 90-something number plus a single digit. This square is a 9. This square and this square have to add up to 10. Can't obviously be 1, 9, could be 2, 8, could be 3, 7. Not sure. Not sure how to disambiguate that. Let's look at this one. So this one, what do we know about this one? We know this can't be a 90 number. Oh, now that is beautiful. We can do something with this, I think. Yes, we can. So let's ask ourselves the basic question. What is the form of this? Is it a 2-digit number plus a 2-digit number? Now, if it was, we'd have two things we could deduce from that. The first would be that these two squares would have to add up to 10. The second would be that these two squares would have to add up to 9, because it would have to be something like, I don't know, 16 plus 84 or something. Obviously that doesn't work, but something like that. Now, if these two add up to 9, not many options are available there. 3, 6 isn't possible, 4, 5 isn't possible, and 2, 7 isn't possible. So this would have to be 1, 8. But now, how can I make those two add up to 10? I can't anymore, because 1, 9 is impossible, 2, 8 is impossible, 3, 7 is impossible, 4, 6 is impossible. So this is not a 2-digit number plus a 2-digit number. So this one of these sides must be a 90 number, and it can't be that one. That square, I think, has to be a 9. And these two squares have to sum up to 10, and they must be 2, 8, because they can't be 3, 7, 4, 6 or 1, 9. That is very beautiful. Oh, now we can... Well, I think we could have done something with this L clue before, because let's look at this side of the clue. This cannot be a 70 number, because that would immediately be higher than 50. So this is a single digit, which means this is a 4. That's a gimme right at the start. So now these two squares have to add up to 10, so this is a 3, 7. And these two digits have to add up to 10, and Ah, now that's good. That's very good, because they can't be 4, 6. They can't be 2, 8. They can't be 3, 7. So these two squares have to be 1 and 9, and there's a 9 there. So that's 1. That's 9. This is 1 now by normal Sudoku. Look, there's a 1 down there. These 3 squares have got to be 5, 6, 7 to complete the row. These 3 squares have got to be 3, 5, 6 to complete the box. I think should we just carry on? We'll carry on working our way down the grid. This is an L clue. So how can we... Well, this can't be this can't be a 2-digit clue plus a 2-digit clue. There's just no way. Yeah, but let's look at that. I mean, there's a few ways of seeing that very obviously, but if we look at this square, which would be the 10, if this is a 2-digit sum plus a 2-digit sum, this would be a tens digit. So it has to be a number lower than 4, and it could only be a 2 because there's a 1 and a 3 in the column. Well, if that's a 2 and this was, say, 27, this would obviously have to be 23, and that would repeat the 2 in the row. So this is a 1-digit number plus a 40 number. The 4 here means this is not possible for this to be a 4, so this has to be a 4. This is a cool puzzle. Now these two squares now have to add up to 10. Can't be 1, 9, 3, 7 or 4, 6, so they are 2 and 8. Well, they would be if I could, oh dear, do that properly. They must be like that. These squares are 7 and 9 to complete the row. And now presumably we use this clue, do we? So this... Ah, the 9 here is massive for this C clue because it can't be a 90 number plus a single digit. So this is a 2-digit number plus another 2-digit number. So, and that being the case, these two squares have got to sum up to 10. They can't be 1, 9, 4, 6 or 3, 7. So these are 2 and 8. Oh, this square has to be a 3. Look, there's 3's here, and this is a 3. So this is a 6 because it's got to be 32 or 38 plus 62 or 68. This is a 5. What a gorgeous puzzle this is. This is a sort of thing I think that could really catch on as a type because it's just got lovely, lovely logic. Okay, so what should we do now? Tempted to look at this clue actually because I've got a 3 and a 4 in the column. So if this is a 2-digit number plus a 2-digit number, this would have to be a 6, and these two squares would have to add up to 10, and they couldn't be 3, 7 or 4, 6, so they could be quite a lot of things. If this is a 1-digit number plus a 2-digit number, then this couldn't be the 2-digit number. So this would have to be a 1-digit number and this would have to be a 9. And these two would add up to 10 again though. So these always add to 10. This is a 6 or a 9. Bobbins, I don't think that's good enough. I don't think we're going to get anything from that. Just looking at this again, these two squares have got to add up to 10, and this one can't be 3, 7 anymore, or 1, 9. So this could be 6, 4 in that direction. So that's a 6 or a 4. Or 2 or 8, I guess. Yeah, okay, that's not going to be good enough. Right, so the only clue I think we've got left to look at, therefore, is this one. So let's carry on. Yes, we've got 3 9s. So can this clue be a single digit plus a double digit number? If it was, there'd have to be a 9 here or here, and there can't be. So no, this is a 2-digit number plus a 2-digit number, which means these two squares sum to 10. And they can't be 4, 6. Is there anything else they can't be? Oh, they can't be 1, 9. So these two squares are either 2 and 8 or 3 and 7. I can't see how to... Maybe I'm missing something there. So this is 2, 8 or 3, 7. These two squares have got to sum up to 9. That might be better. But these two have to sum up to 9. They can't be 4, 5. They can't be 3, 6. So this is either 2, 7 or 1, 8. But we've got this trick again, haven't we? Because yes, we have. If we make these 2 and 7, I cannot ever make these two squares add up to 10 anymore, because 2, 8 and 3, 7 would be ruled out. These two squares have got to be 1 and 8. Therefore, these two squares can never be 2 and 8. Which gives us a 3, 7 pair look now in this column. So this square can't be a 3. And this one can't be a 1 or an 8. Now that was a units digit, so if this can't be 1 or 8, this can't be 2 or 9. Okay. So that's good, but it's not enough, is it? 3, 7, 3, 7. Oh, look, we've got a 1 here. That means there's a 1 in one of those two squares. That can't be a 1, because if it was a 1, we'd have 41 plus 59. There'd have to be a C on this boundary. That is a 1. Oh, that's huge. Now that's an 8. That's a 1. And there's a 5 there. Look, I could get rid of that 5. Oh, I've got the same thing here. If I make this a 3, look at that. If that's a 3, this is 93 plus 7. That would have to be a C. That, good grief. I think this has to be a 6. So that's a 5 and that's a 3. That means that's a 3 and that's a 7. Wow. Okay, so now let me look at this now. So so there's now, look at those two 3s. In fact, that's 3 C's that square, so that's a 7 and a 3 in that order. These squares are 2, 6 and 8. That one can't be a 6. This is a 2 or an 8. Two, 6, 8 triple here. So what are those squares equal to? 9 and 4, is that? We know there's a 3 down here. And what else do we know? Oh, we've now got some movement over here, so we can put 3s in over on this side. This 8 sees this square. Oh, that forces that one to be an 8. Look, these are 2, 6. These are 2, 3. These must be 5, 6. Oopsie, I need to do that. 5, 6. And so this sum is now completed. This sum is not completed. This sum is not. We've got rid of one digit there. So if this can't, we got rid of an 8. So this square can no longer be a 2. And that square can't be a 2. Why can't it be a 2? What a puzzle. If that's a 2, that's a 6. And now I've got 32 plus 68, which equals 100, and then have to be a C at the boundary. Wow, how on earth do you design this? This is absolutely bonkers. There's a 6 here, this is a 2. So now these two have to add up to 10, so this is an 8. Now that's interesting, because now we've got 8, 8 here, so this is going to be an 8, and that means this is a units digit, and that's a 2. Now that's a 2, look, by normal Sudoku rules. $43 here, so that can't be a 7, because that would add to 50. Now, can we just write this in then? So this could be a 6. No, we can't, look, because this could be 32 plus 68, or it could just be 2 plus 98. So 6 and 9, I don't think we know what order that is yet. These two squares have got to be 4 and 9. And oh, look, we can do normal Sudoku. 4s and 3s here are in a pair there. That's 3, 4 pair. That means that's a 9. That's a 4. 4 over here now. 9. 9 does resolve that. So that was a 2-digit sum plus a 2-digit sum. This is a 6. That means that's a 6. That's a 5. Must be a 5 down there. One of these squares is a 1. Oh, in fact, it's this one. You can see the 1 over there. That's a 5 now because of the 6 here. These two squares are a 6, 7 pair, therefore. 7, that must be a 7 just by normal Sudoku, which means this square is a 9. These two squares now have got to be 5 and 6. Therefore, this is a 5. This square should be an 8. That's, oh, brilliant. That's an 8. That's a 2. That's a 2. That's an 8. There's a 1 over here, look. 9, 2, 3. 6, 7. What am I meant to see next? 5s. This is a 6 by normal Sudoku. Should have seen that before. These 6s interacting. 7's now in one of those squares. There's a 9 in one of these two squares. 3's. 3 over here. I don't believe it. Have a look at this box. You might want to include. That's unbelievable. Yeah, okay, so have a look at these two squares. So, if I make this a 7, what happens? This has to now be a 4. And all of a sudden, I've got 47 plus 3 is 50, and there would have to be an L here. I could understand this puzzle a bit if this negative constraint came up once or twice, but it comes up over and over again. It's absolutely bananas. So this square can't be a 7. This is going to have to be a 7. That means that's a 3, that's a 9, that's a 4. That's a 4 and that's a 3. That's a 7 and that's a 9. There's a 9 down here now. In fact, I'm doing quite well now in some of these. Ah, this 8 is good. That forces this one to be an 8, that to be a 1. That gives us a 1 here. We still need to place, what's that going to be, a 3 down here? Looks like it. 3-9 combo there. And this is going to have to be a 2-7 combo. Let me just make those pencil marks like this. Now we have 93 here, so this square can't be a 7. Otherwise we'd have 100 and this would have to be a C, and it's not. So the 7 is in the bottom row, which means this is a 2, that's a 7, this is a 2, this is a 3, this is a 3, this is a 9, this is a 9, this is a 4. Now that's a 4. Oh no. Have I broken it? Oh please no. This is obviously a deadly pattern that must be resolved, I reckon, by the by something creating a... Yes, it does here. Look. If this is 47, if I put a 7 here, this square is a 3, so that would be 47 plus 3 is 50, and I'd have to have an L there. So this is not 7. Unbelievable. Is that saying it? Yes? Yes. Brilliant. What a brilliant puzzle that is. Oh, guys, I hope you enjoyed that as much as I did. That is a sensational piece of setting. Sensational. Come back later for another edition of Cracking the Cryptic.